All right, we're on 4.3, solving quadratic equations by factoring. So here's what we've done so far this chapter. We graphed a bunch of parabolas, right? And we're like, hey, that's fine. Day 2, on Friday, we graphed parabolas and we tried to see where they cross the x-axis. We solved them by graphing. But we found out that wasn't really like the best way, right? Because we were like, it's in between -1 and 0. I don't really know where it is, right? That's not a good way to do it. It's not accurate. So today, we're going to solve by factoring. It's not the only way to do it again, but typically, once you're good at it, factoring is pretty quick and it's usually easier than the other options I have coming later in the chapter. So that's what we're going to do today, solve by factoring. So on the back, let's glance there really quickly. Any day before today, maybe, these were all equal to what? They were usually equal to y before today. Equal to y, right? Whenever you solve a parabola, what is it? What's another word for root? Solution, zeros, x-intercept, right? So if you're trying to find the x-intercept, it's where the graph crosses the x-axis. So to find x, you set y to 0, right? So that's what they've done. They've set all the y's to 0. Do you understand how that's the only difference today? Okay? So when we solve these, we're finding where the x-intercepts are. We're solving a parabola. That's the goal, okay? Before we can get to solving it, we should probably remember how to factor. So back to the front. Why are you not working? Okay, I'll just do that. There's different ways to factor, and we'll talk about these, but I don't know that we need to do that today. I looked over your homework. I looked ahead. We've already talked about difference of squares. Great. We've already talked about GCF. Fine. We've talked about bottoms up, which is basically what this is referring to. Sum and difference of cubes we do need to talk about. That is new to you this year. You've never seen it before. It's not terribly difficult, but if I can skip it today, I'm going to. So at some point, we're going to have to cover sum and difference of cubes, but not today. Okay? So we're going to move on. And then I'll cover factor by grouping in a second. So let's look at the examples. Everybody in here can do number 6. I want everybody to go ahead and start with number 6. You factor it. So you factor, probably by bottoms up. Most of you do that, I think. Step 1 is take out GCF if there is one other than a 1. Is there GCF other than 1? No, right? So then you do whatever you do for bottoms up. So everybody try it. If there's a 1 in front of the square, the answer is the pair. Very good. While you do that, I'm going to write these on one page at a time because it's just kind of too much. What number are we on? We're doing 6 first. Check with the neighbors, see if you get it right. All right, I'll stop there. Okay, what did you guys get? X minus 4, x minus 8, right? Oh, red. Here we go. Anybody not get that? Huh?
Number 6.
Come on! I told you. Dang it.
I can't wait to watch this.
Is that it?
Yeah.
Did I write it right?
Yeah.
Oh, okay, cool. Okay. See, I was going to do this before you guys came in, and I didn't have time. I actually taught all day, so it's kind of hard to do. Okay, minus 8, minus 4, minus 4, minus 8. Is everybody okay? Easy or fine? You don't need my help? Excellent, great, because you shouldn't. It's old. All right, 29. We're going to jump to that one next. I'm trying to go from like super easy to harder as we go. So 29, step 1. GCF, if there is one other than 1. Is there a GCF other than 1? No. So factor, bottoms up, whatever you do. Get the answer. When you're ready, check it with mine. If you get it wrong, say something. Make me do it for you, please. Anyone not getting it and need me to work it out for you? You forgot how to do it or whatever. Everybody okay? Great. So it's not new, right? I haven't done anything new. Can I move on? Okay. Let's try this one. Number 4. What's the first step whenever you factor? GCF. What is our GCF? 5x. What's left over? 7x minus 3. Am I done? Yeah, I'm done. Okay, so here's how you can tell if you're done. Whenever you have a GCF of 1 in the parentheses, and if the exponents are 1s, you're done. So let's go back to this one. What's the GCF here? 1, GCF here. 1, exponent 1, exponent 1. That's how you can tell that you're done. Is that okay? Okay, so let's try this one. Number 32. Step 1. GCF is 4 z squared, right? Pull that out, see what's left over. What do we have left? 2x squared minus x minus 3. Pause there, make sure you understand it. Is everybody okay? Okay. Whenever you have that, it looks like this is probably going to end up factoring like this, right? And I still need that 4z squared. That doesn't go away, all right? But I don't really like looking at it anymore. It makes everything a little bit confusing for me. So I go ahead and I skip some space. I write what the final answer is going to look like, I think, right? And then I can ignore the 4z squared. And I can factor this just like the last one, or the one before it, I guess, doing bottoms up again. So let's go ahead and factor this. And what do you get? Say it again. You should get 2x minus 3 and x plus 1. If you don't, make me do it for you. Can you have the x plus 1 in front of the 2x minus 3? Sure, it doesn't matter, right? Ask me a question. So everybody's okay. Everybody factored the front except for number 5. Totally fine. You don't need help. Everything's fine. I shouldn't have recorded this class. The other class had questions. So now if somebody watches the video, I'm just going to be like, oh, look at the answers. Okay, number 5. 18x squared minus 3x plus 24x minus 4. Here we go. With this one, it's totally fine if you combine like terms and you say 18x squared plus 21x minus 4 and factor that. That's totally fine. and it would probably work, but I don't think it's going to be super fun. So in Algebra 2, whenever you have 4 or more things, you see how that's 4 like pieces, right? You typically are being led to the idea that it's probably factor by grouping. So factor by grouping is where you actually group them. That's why it's called factor by grouping, okay? And then you go from there. So again, for today, I have to show you easy examples so that when they're hard, they're not so hard. But I know that you're going to be tempted to just say plus 21x and solve it that way. I get that. But for today, don't. Do it my way, so that way when it's not a choice, when you have to do what I'm showing you right now, you'll know how. Does that make sense? Okay? So after today, it won't be where you can combine like terms in the middle. You'll have to do this anyway. So do this. Am I making sense? Okay? So factor by grouping is where you group half of it and you group half of it. Okay? What's the GCF here? 3x. What's left over? 6x minus 1. Does everybody get that? You bring down this plus sign, okay? Comes down. And GCF again. 4. What's left? 6x minus 1. That's not a coincidence. If these don't match, and this is the way you're supposed to do it, you did something wrong, okay? Whatever's written twice, we write once. Whatever's left over, I typically put behind it. This is the distributive property backwards, okay? If they're both times 6x minus 1, then you can put 6x minus 1 by itself, and then the 3x and the 4 next to it. That's like the distributive property or FOIL backwards, basically. Okay? So some Algebra 1 teachers teach factoring like this instead of bottoms up or instead of guess and check or whatever, and it's a totally fine method. In this class, we're going to have to do it sometimes. Okay? I want to tell you some more things. This section is a little bit tricky because I'm showing you as many examples as I can, and they're all different. Every single question has been different, right? So with this, like sometimes there's a negative sign here and you have to do something else, and sometimes you can combine them. And so I'm going to show you as much as I can, but you're still going to come up to questions that you maybe don't remember from Algebra 1 that you're supposed to, but that's fine. So I'm going to do the best I can. So today you don't want to just memorize what I'm doing. You want to actually understand it, because if you just memorize it, you're going to get to one that doesn't look like one that I've shown you, and then you don't know what to do. Does that make sense to you? It's not Algebra 1 anymore where you had a 20-question worksheet and they all looked the same, right? Every question today has been factor, but every question has been completely different than the one before it. Am I making sense? Okay, go ahead, Sam. What was your question?
I was going to ask, since this is like when we would do regular factoring,
Mm-hmm.
if we got the same, like how,
If you're going to do bottoms up instead, is that what you're saying?
no, like how 6x minus 1 shows up twice.
Yes.
On regular factoring, we put the square, but on this one, since it's all one, we don't.
Okay, that's a good question. What she's saying is she wants to write 6x minus 1 squared. So here's why we don't. See this plus sign here? What you said would have looked like this. And that's true. But this plus sign, the 6x minus 1s aren't being multiplied times each other. They're being multiplied times a 3x and a 4. So I said, hey, instead of doing 6x minus 1 twice, I'm going to say they're both being multiplied by the 3x and the 4. So whenever you do factor by grouping, whatever's written twice, you write once. If I had written the 6x minus 1 again down here, and I tried to FOIL this out, I would not get the original question back. It's like you did it too many times. Do you get the difference between the two questions? Okay, that's a good question. Jake?
Well, when you FOIL, I was just going to ask when you FOIL it.
If you FOIL the right answer, uh-huh.
Yeah, is that how they're multiplying? Like they're multiplying them?
First, outer, inner, last, is that what you mean?
Yeah.
Uh-huh.
Well, there.
Do you need help with FOIL, is that what you're saying?
Well, I'm asking like when you FOIL, if that's what those are going to be multiplied together.
Yeah, they're going to be multiplied together when we FOIL. This is like unfoil. This is backwards. Yeah. Is everybody kind of okay with that one? So we're going to get more practice. That's why it's so important. That's why I give you the answers in the binder, because I want you to know right away if you're doing something wrong, so you don't learn it wrong and you ask me immediately like, hey, this one's different and I don't understand what to do. So it's super important that you guys do that, which you already do anyway. All right, so we're on the back side now, right? Okay? So the front side said factor period. Okay, good job. The back side says what? Solve. Whenever they want you to solve something, they want like x equals 7 or something like that, right? So the front side was just to kind of get us warmed up and ready for the back side. The back side, instead of a y, it's 0 because they're going to find the x-intercepts, which is where the graph crosses the x-axis, which is the answer to a parabola, which is a root solution x-intercept, right? It's all connected, even though it doesn't seem like it is. So let's just focus on one thing at a time. Today we're solving by factoring. So you ignore the equal to 0 for right now, and you just factor the thing. So let's factor number 11. What's the first step? GCF. What is my GCF on number 11? 6x. Is everybody comfortable with 6x? When the numbers get really big, these aren't big, I know that, but when the numbers get really big, if you're confused about what the GCF might be, one of the checks that I do is if they're all even, you can at least pull out a what? A 2, right? And maybe higher than that, but it's at least like a start, okay? So 6x comes out. What's left over? 2x minus 3. Is that right? Is everybody okay? If they had said factor, we'd be done, right? But they said solve. So again, something from Algebra 1, you're supposed to remember. You don't, it's okay. It's called the zero product property. Whenever you have 2 or more things multiplied set equal to 0, something times something equals 0. You pull them apart, and you set them equal to 0 separately. It is a rule. It's called zero product property. Whenever you have 2 or more things being multiplied equal to 0, you pull them apart and you set them equal to 0 separately. I should be able to be like, okay, finish it. This is totally Algebra 1 now, right? How do I get x alone here? Divide by 6, so x is 0. Don't be afraid of 0, it's fine. How do I get x alone here? Add 3, divide by 2, so 3 over 2. Did I solve? I solved it, right? X is something, right? It's 0 and it's 3 over 2. If it was a test or a quiz and you had time, what could you do? Plug them in, check them, right? You could go back to the original question, plug these in, and they better give you 0 or you did something wrong. Are you okay with me not doing that, though? Like, we don't have time for that today. But if you ever had time on a test or quiz, I wouldn't do it on homework, just check mine. On a test or quiz, you go back, you plug them in, and if it doesn't give you the equal to 0, then you screwed up somewhere. Okay? Next, number 12. 12x squared minus 2x minus 2 is equal to 0. Step 1. GCF. What is it? 2. What's left over? 6x squared minus x minus 1, right? So I have to keep factoring, right? It looks like it's going to be like this. Does everybody understand how I'm pretty sure that's what's going to happen? Right? So I don't like to look at the 2 anymore. That's confusing for me. But you also can't forget it. Okay? So I'm going to go ahead and factor this. So factor that for me. Yeah, if we don't, we can do it tomorrow. It's no big deal. Okay, how's that factor? Or are you not done yet? Sorry. What'd you get, Maddie? Yeah, and then you have to divide by the 6, right? For bottoms up, right? So you guys should get your pair is a negative 3 and a positive 2. So x minus 3x plus 2. Hopefully you picked that right. You divide by that 6. You reduce, so x minus a half, x plus a third. And then you bottoms up. So I get 2x minus 1 and, bless you, 3x plus 1. That's how it would factor. Are you okay with that? Okay. So now we have to actually solve the thing, right? Whenever you have 2 or more things being multiplied, set equal to 0, you pull them apart, you set them equal to 0 separately. So 2 equals 0. 2x minus 1 equals 0. 3x plus 1 equals 0. I just pulled them all apart. Does 2 equal 0? We go no, right? That's not even true. That doesn't make sense. What's x here? Yeah, add the 1 divided by 2. What's x here? Negative 1/3. So I get 1/2, and I get negative 1/3. Ask me a question. Are you sure? So let me pause for 2 seconds and like backtrack and show you some options here. First of all, if you don't like this, if that doesn't really make sense to you, that 2 doesn't equal 0, ignore it. We could have just divided both sides by 2 here, and then you would have had this equals 0 anyway. Does that make sense? One of those needs to make sense to you. Ask me if they don't. When we had these two answers, because they didn't technically ask me to factor, couldn't I have like gotten those two answers from here? I didn't really have to actually bottoms up. Do you see how it would be positive 1/2 and negative 1/3? Do you see what I'm saying? But I don't want you to get confused. If they said factor and like not solve, you would have to give me this. But because they said solve, either way your answer is this. Get there however you want. It's just an option if you don't want to do what I just did, if you want to save some time. Okay? Okay. How many answers do I have? 2. What's the degree of this polynomial? What's the highest degree of the function? Degree. 2. How many did I have here? 2. What's the degree? 2. That's not an accident either. Okay? So the highest degree of the function, we'll get there some other day, but it's kind of like you to know it now. If it's degree 2, you should have 2 answers. It gets more involved than that, but we'll get there later. Okay? 41. X squared plus 13 equals 17. Why is this one different than the other ones? It's not equal to 0, right? So let's go ahead and do that. It's going to be x squared, what? Minus 4 equals 0? How's that factor? What's that called? Difference of squares? So how's that factor? X minus 2, x plus 2, or either way, right? So what do I do now? If they said factor, I'd be done, but they said solve. So pull them apart, 7 equal to 0 separately, so x is 2 and negative 2. Anybody confused? You sure? Okay. 42. Why is this one different? It's okay not to have a GCF. Why is this one different from all the other ones? There's a negative in front, right? There's a negative LC. If I were graphing this, what would that mean? It opens down, right? I'm not, so I don't care. But if I'm not graphing it, it doesn't matter what I do or where I move things, right? Can you factor with a negative in front? Have we ever done that? We've never done that, right? So I can't factor it this way. So I can divide everything by a negative 1, multiply everything by a negative 1, move all this stuff to the right. You can do whatever you want, just make that front number a positive. Does that make sense? So I'm going to divide everything by a negative 1 because it makes sense to me, okay? So that's going to be 3x squared plus 10x minus 8 equals 0. Okay? I'm going to save you time because you guys know how to factor. We're going to get x plus 4 and 3x minus 2. Jump to that step with me, if you will. Okay? So pull them apart. And what's x in the first equation? Negative 4 and 2/3. Is that okay? That's going to happen a lot from here on out, too, with notes, where I skip steps that you should know by now, like the factoring. We've done it, like, I don't know, 6 times today. So if that's something I skipped and you don't think you still know it, you need to come and see me later, and I'm happy to actually work it out with you. Okay, so it's going to really be on you to let me know if you need more help than what I gave you. Because if not, we'll never get done in class. Okay, so let's talk about what this means before we do the last 2 questions. If we were graphing this, what would this be? What's the, going back just to step 1, what is that? A parabola, right? It opens down. What did we find? Where it crosses the x-axis. So I know at negative 4 and I know at 2/3. I know it opens down. I don't know where my vertex is. I didn't do that today. But would it be a max or a min? A max, right? So there's no way if I had graphed this that I would have known that 2/3 was the answer. You can't guess that. Do you see what I'm saying? So that's why this method is so important. Okay? So we don't want to do what we did on Friday where we'd be like, it's in between 0 and 1, but I don't really know where. No, today I know it's at 0.6 repeating. That's my answer. Is that okay? Okay. So let's go to number 1 on the bottom. This says, write a quadratic equation in standard form with the given roots. So really short version, standard form looks like this. Descending order equal to 0. You're not allowed to have fractions or decimals in standard form. We'll deal with that later. So they gave me these roots. Again, what is root?
0.
Solution, zeros, x-intercepts, da-da-da, whatever. What this means is they gave me the answer and they want the question. So I shouldn't have gone back here. I'll just write it myself. So they gave me these and they want this. They gave me these and they want this. Do you understand? It's just backwards. Is that okay? So with what they gave you, sorry if I'm confusing, flipping around everywhere, but they gave me x-intercept is -8. They gave me x-intercept is 5. They literally told me x is this, x is that. But if you didn't know the word root from the directions, you wouldn't have a clue how to start this. Does that make sense? Okay? So the step above the answer, right? The step above here was what? Equal to 0. Very good. So I want these to be equal to 0. So I'm going to write x plus 8 equals 0. Excellent. X minus 5 equals 0. Do you guys get? I'm literally just going backwards. Okay? The step above this one, if we go the other direction, I'm here, right? So what do I need to do? Like shove them together, right? We pulled them apart, so now we need to shove them together. Do you guys understand how we're just going backwards? What do you think you do now? Foil. Excellent. When you see two things next to each other like that, it's probably foil, right? So go ahead and foil that. And what do you get? You should get x squared plus 3x minus 40 equals 0. If you don't, say something. Are you guys okay? Fine? That's in descending order. It's equal to 0, so it's probably good. That's standard form. Okay? Let's do the next one. Number 3. They said -2/3 and 5/2. So again, I know it's x equals that, and I know it's x equals that. Okay? So now what do I want them equal to? 0. So x plus 2/3 equals 0, and x minus 5/2 equals 0. They're pulled apart, so what do I want to do? Shove them together. X plus, whoops, that's plus sign, 2/3 and x minus 5/2. So I could foil like this. I kind of don't want to, though. Why do I not want to foil that if I can help it? Fractions. It's not super fun. You can, but I don't want to. Plus, in standard form, when I'm done, I'd have to get rid of the fraction anyway. Does anybody have any idea how to make this a little bit easier? Decimals is really the same as fractions, but I see what you're saying. Maddie? Yeah, bottoms up. Right? Couldn't we bottoms up with this? Isn't that really 3x plus 2? And isn't that really 2x minus 5? Isn't that the same? Do you guys see what I'm saying? So you can foil if you want to, but you're going to have to deal with it later anyway, so you might as well make it easier now. So go ahead and foil it now and see what you get. If you're struggling with foiling, let me know. I'll do it for you. I'm happy to do that. So you get 6x squared minus 11x minus, what did you guys get? 10. Excellent. If we had foiled here, we would have had, I think, over 2 a bunch. And we would have had to multiply everything by 2. Because standard form can't have a fraction. So when we didn't do it that way, it made it a little bit easier, saved us a step, I guess. Ask me a question. Are you sure? So again, I know this whole chapter seems disconnected. I understand that, but it's all talking about parabolas, just in different ways. Okay?